Well, hello and welcome to our next topic. We're going to start talking about redox reactions, which is a new type of reaction that you will be familiar with some of them by experience, but not necessarily knowing that they're redox reactions. In this, we will do a little bit more than what is typically covered in the Year 11 curriculum, just to prep you for Year 12, because this is a very, very important topic for Unit 3-4. So if you are struggling with it, because it can be a little bit confusing, make sure you ask plenty of questions in class, and this is something we want to try and bed down to give you the best chance of success next year. So let's get going. What we're going to be looking at in this video is looking at how to explain the importance of redox reactions in everyday life, so where they turn up and examples of these, outline the different ways in which they have been defined historically and our current definition, be able to understand that oxidation and reduction occur simultaneously, and identify redox reactions when looking at different reactions. So let's get going. Redox reactions encompass a large number of reactions that you're already familiar with. So anytime we're looking at the burning of fuels for coal, for electricity, petrol for cars, any combustion reaction is actually also a redox reaction. Okay, so is the corrosion of metals, the processing of mineral ores to extract metals, so going from an ore like bauxite or iron ore into that metal, getting rid of that oxide coating, is actually a redox reaction as well. As are respiration and photosynthesis, the production of fertilizers and batteries in the way batteries work, which is what the focus is in Year 12, are redox processes. So as you can expect, there are many, many different reactions that are critical to the operation of our society and the way we do chemistry that require and operate due to redox reactions. When we define redox, vocabulary is key, okay? So the vocabulary in this can get a little bit confusing, okay? The word redox is actually a contraction of the words reduction and oxidation. Okay, so we can see that we have taken red and ox, so we've got redox, and this is a good reminder that these processes always happen at the same time. If we look at oxidation, which is the first that was actually defined, we can see that we know that many chemicals react with oxygen to form different compounds. Okay, copper reacting with oxygen to form copper oxide, we saw in the first reactions we did back when we started chem. All the ores in our Earth's crust have reacted with oxygen, so they are ore compounds rather than pure metals. Previously, these were sort of described as oxidation reactions because they knew that they reacted with oxygen. So this oxidation was the adding in of oxygen. Okay, so if something gained oxygen, it was said to be being oxidized. This is seen in many common experiments that were conducted in order to come up with these ideas. This includes the combination of oxygen with things like carbon, sulfur, or iron to form their respective oxides, so carbon dioxide, sulfur dioxide, and then iron oxide here, which is our rusting process. All of these were common known reactions, and they seem to be consistent in the fact that the formation of the oxide, when you add in oxygen, the compound's properties changed. So if you have a look, this is an example here where we can say that the reaction of copper oxide with hydrogen gas will displace the oxygen, so we can go from copper oxide to pure copper metal by adding in hydrogen, okay, and removing the oxygen. But the hydrogen in the process will gain the oxygen from the copper and form water, so it will have been oxidized. So if we say that they happen simultaneously, then if oxidation is the gaining of oxygen, then we need to look at reduction. And originally reduction was defined as the process that led to a compound losing oxygen. Okay, so in the example that we saw before with the copper oxide, plus hydrogen, we can say here that the copper lost oxygen. Okay, the copper was losing oxygen. So it would have been considered to be reduced. When oxygen is removed from a substance, we refer to that term as being reduced, and it was the opposite process of oxidation. So if we look at iron oxide here, in the case of smelting to form iron, we can see Fe2O3 solid in the presence of carbon monoxide will yield iron solid and carbon dioxide. In this case, the iron has lost the oxygen, loss of oxygen, so it has been reduced, and the carbon monoxide has gained oxygen in order to become carbon dioxide, so we could say that it has been oxidized. Okay, so the process of oxidation has occurred there. So that's great, but as with many things in chemistry, it doesn't cover all the situations. So over time, the definition of oxidation and reduction has been expanded, or more I should say, it's been refined, okay, because we've learnt more about the chemistry and what's actually happening. So this idea of oxidation and reduction were expanded to include reactions where hydrogen was increased or decreased, okay, so it was stopped being just based around oxygen. Okay, so if we have a look here, MnO2 plus 4HCl goes to MnCl2 plus H2O plus Cl2 gas. We can see here that the Cl has lost oxygen, HCl has lost hydrogen, sorry, not oxygen, it's lost hydrogen, going from Cl minus into Cl2. So this has actually been oxidized. Okay, and then the MnO2 here has actually been reduced. So this one doesn't actually follow the previous rules. Okay, so while reduction has also become, because these reactions are very, very prevalent, okay, there's numbers of ways to define them. In this case, we also can now define reduction according to the gain in hydrogen. So if we have a look here, C2H4, which is our ethene, if you remember back to organic, when we add hydrogen in, you may remember this as being hydrogenation, the addition of hydrogen across the double bond. This is actually a reduction reaction when we form ethane. Okay, so what we've done here is we've added in hydrogen across the double bond. This increases the amount of hydrogen, so is defined as reduction. Both of those seem to account for a large number of reactions, but couldn't give us definitions for reduction and oxidation where the reaction didn't involve oxygen or hydrogen. So it was eventually refined that our definition of redox is occurring because of a transfer of electrons. So we've just finished acids and bases, where we talked about an acid-base reaction being defined by a transfer of protons. Okay, here it's all about electrons. So redox reactions are defined now in the modern day as a transfer of electrons. So we define oxidation as the loss of electrons. Okay, so if we look back, we could say in the case of iron, when we talked about it forming oxygen, it went from iron oxide, it went from being a pure metal into an ionic substance, which is the case of Fe2O3. This is now ionic. So we know that the ion in here is actually Fe3+, if we look at the ionic formula. So we can see that the ion has lost 3 electrons. So this loss of electrons is considered to be oxidation. Similarly, reduction being the opposite of that is the gain of electrons. And again, if we have a look at this, if we were to write out the iron reaction, it's going to be a reaction with oxygen gas, which is going to form the iron oxide Fe2O3, and in this case it's ionic, so we know that all the oxygens are going to be -2. So this has gone from oxygen gas to -2 oxide, so we know it must have gained the electrons from the ion. So this would be reduction. So the formation of all ionic compounds, okay, so the formation of an ionic bond is by definition a redox reaction where we have electrons being lost and gained. Just with like acid and base reactions, we can't have something being donated if it's not being accepted. So redox reactions, oxidation and reduction, always occur simultaneously. We can't have something gaining electrons if there isn't something giving them away, because electrons don't float around on their own. So there's a couple of mnemonics to help you remember this. One being oil rig, oxidation is loss of electrons, reduction is gain of electrons. Or if you happen to like lions, Leo the lion says go, where loss of electrons is oxidation, gain of electrons is reduction. I tend to use this one here, oil rig, a lot in class. So as I mentioned, when we talk about electron transfer, this means that we are talking about the formation of ionic compounds. Because we know that these occur due to the transfer of electrons, by definition, the formation of an ionic compound is always going to be a redox reaction, which is one way we can start to identify them. Okay, so this is our quick introduction to redox. You should be able to explain the importance of redox reactions in life, so know examples of where these reactions occur. Outline the different ways that they have been defined historically, so through the addition of oxygen, loss of hydrogen, addition of hydrogen, or through electrons, which is our modern day one. Understand that oxidation and reduction occur simultaneously, and be able to evaluate equations based on their definitions to determine if a redox reaction has occurred. So in this case, we're going to be looking at the moment for the formation of ionic bonds. Has something lost or gained electrons in the process? That's it for the introduction to redox. Make sure you make a vocabulary list. The words can get a little bit confusing, and I'll see you in class.